How's it going today, guys? Mr. Allen here. We're going to be talking about a greatest common factor problem-solving problem, or sometimes we just call it a GCF, right? Greatest common factor problem-solving problem. I'm going to read through it. While I read through it, I want you to visualize. I want you to think about what's going on. Don't try to solve anything yet, unless you want to pause the video like right now and try to solve it. Then watch the video. That's also a great strategy, but let's read it. There are 24 sixth graders and 40 seventh graders. Mr. Chan wants to divide both grades into groups of equal size, with the greatest possible number of students in each group. How many students will be in each group? I'm going to start by underlining the information that I think is important. Okay, if you want to pause the video and see if you would underline the same information, maybe you want to pause and do that. But that's what I'm going to do first. So I'm going to say there are 24 sixth graders. That's pretty important, right? 40 seventh graders, also very important. Mr. Chan wants to divide both grades into groups of equal size, with the greatest possible number of students in each group. How many students will be in each group? I personally am a big fan of highlighting the actual question in these sorts of problems, in these sorts of greatest common factor story problems, because there's a lot of questions that can be asked. Some of these questions will have multiple parts, multiple questions. So I like to highlight so that at the end I can go back and check and see if I've actually answered the question. So let's go through this. So there's these sixth graders, there's these seventh graders, and Mr. Chan wants to divide the groups or the grades into groups of equal size. Okay, so there's always these like specific restrictions or specifications that in these story problems that are just specific. So it's important to pay attention when it says something like equal size or greatest possible number of students in each group. So he's trying to make the largest sized group possible, and they have to be equal. Now, we could just combine all the students together and wow, we have one group, right? So it's an equal size because there's nothing to compare it to, and it would be the greatest possible number. But the important thing that I didn't underline yet, because I wanted to see if you guys would have caught it, is Mr. Chan wants to divide both grades into groups of equal size. So he's not combining grades. He's not even putting sixth graders and seventh graders in the same group. He is combining both grades individually, and it's sometimes hard to interpret that from reading this problem, but that's why it's important to read this slowly. It's important to underline stuff and then read it a second time and go through it. Make sure you've understood all the information there is to get. So I'm going to go down here. I'm going to say sixth graders are going in their own group. Seventh graders also going in their own group. Okay. There are 24 sixth graders, and there are 40 seventh graders. Now, I want to start talking about the size groups that I can make. I'm going to start with sixth graders before even getting to seventh grade. I'm just going to do one grade at a time, okay? So, excuse me. 24 sixth graders. I could make one group of 24. That'd be a big group, okay? I could do two students per group, right? So 24 students divided into groups of 2. So I'd have 12 groups. I could do 3, right? I could say, okay, 24 students into groups of 3. Could have 24 students be divided into groups of 4. How about 5? Could I have 24 students of equal size divided into groups of 5? No, I could not, right? So 5 is not an option. How about 6? I could do 6, 7, nope, 8. I could divide my 24 students into groups of 8 students. 9, no, 10, no, 11, no, 12, 13, 14, 15, so no, in between 12, because that's halfway. I'm not going to have another factor of 24 until 24 itself. So these are all my group size options for 24 students, right? If I have 24 students, I could make groups of 3 students, 4 students, 6 students, right? 8 students, 2 students, 1 student, and so forth. How about for my 7th graders now? Let's look at my 7th graders. I could make groups of one student, right? So 40 groups of one student. Not a group if you ask me, but I'm not Mr. Chan. Let's see, I could do groups of 2. Not 3, I could do groups of 4 students. 5, I could do groups of 5. 6, 7, 8, I could do groups of 8. 9, nope. 10. 11, 12 students. No, I couldn't do 12. 13, 14, 15, 16, 17, 18, 19. I could do 20. And 20 is the halfway point. So I know, okay, there's not going to be any numbers that can divide 40 equally after the halfway point, right? So the only last factor is 40 itself. It's important, guys, when you're making these list of factors, right? Because that's what these are. These are all factors of 24 and factors of 40. It's very important that you actually carry it out all the way to the end to the number itself, because you never know. That might be part of the important information depending on the question. So now let's see what we can use this information for. So we know we could divide the students into groups of 1, and so the groups would be all of equal size, right? I'm just going to highlight that because I'm going to reference that so much I think it's worth highlighting. Okay, the groups would be of equal size, but it's not the greatest possible, and I'll highlight that too because that's just that important. It's not the greatest possible option, right? I could do groups of 2. Once again, not the greatest possible option. What do you think is my next possible option of group sizes? If you said 4, you are correct. 5, not an option. 6, not an option. How about 8? 8 is an option. Oh, I don't know what I just did. I accidentally deleted an 8. How about that? I learned something new. Okay. 8. 10, 12, 20, 24, 40, not options. So if I'm trying to make groups of equal size with the greatest possible number of students in each group, then I would say 8 students, right? 8 students in each group. Okay, because that's what the question was. How many students will be in each group? 8 students. So this question I've actually answered pretty early. This was pretty straightforward, but I do want to kind of throw out a couple other questions that maybe might be asked or could have been asked. What if I said, how many groups of 6th graders? How many groups of 6th graders will Mr. Chan have? Well, I would take my 24 6th graders, and I would divide them into groups of 8 students. I have 3 groups. Okay? So, right, we know that this could have been the answer. This could have been the answer if the question was worded differently. What if it said, how many groups of 7th graders? What do you think? Well, if I have 40 7th graders, divided into groups of 8 students, I would have had 5 groups, right? And that would have been the answer to that question. Now, one other question that could have happened is, how many groups total will Mr. Chan have? In which case, I would have said, well, 3 groups and 5 groups would be 8 groups. And I think it's more of a coincidence that it's also the greatest common factor, so that's not something I would rely on every time. But, you know, that's another question that could have been asked. So that wraps it up for this video, guys. If you have a strategy or a tip for your classmates or something you did that helped you think of this problem a little easier, or, you know, anything that helped you out, I encourage you to share it. I encourage you to comment below, let other people know what you did, right? Share that knowledge or that tip, that little bit of advice that you have for other people, all right? And that's all for today.